not just tea, it's green tea. It has to be green. All right, so as far as this class is concerned, we have 2 lectures left, including this lecture. So after today, we only have Tuesday left as the lecture, and then on the 15th, we have our final exam. Okay, so I just wanted, the first thing I want to do is to kind of show you guys where to find your final exam, because unless, okay, instructors are not supposed to change the final time of any class. So if you go to the ARC website, that really should be the reference of how you look up the exam time of any class, not just this one, but any class. So if you click on, if you just hover, calendars and then click on final exam calendar, that is how you find the exam time, the final exam time of any class that you're taking. With this class, we're meeting on Tuesdays and Thursdays, and the class starts at 10:30. So you have to look it up, and it will be this particular item here. It starts between 9:30 and 10:40 a.m. It's a Tuesday-Thursday class, and that's why we have our final exam on Thursday, next Thursday, the 15th, and the exam time itself is almost like class time, except it starts a little bit early. So make sure you remember when we are on the final exam day, the exam will start at 10:15 and not 10:30. And there's a 2-hour final exam, so we'll end at 12:15. If you're done early, you can definitely leave early, but I will be here from 10:15 to 12:15, and you can use the entire 2 hours for your final exam. Yep.
No going over?
Say again?
Is there any going over? Will you allow additional?
No, I'm not gonna go over the exam, in the exam itself, because I think some people will take up all 2 hours to answer the questions. If you guys want to, I can either post the answers after the fact, or I can post another video. But I will have to do it like after the 20th, which is the last day of all the final exams. Are there any questions about the final exam? It is the same kind of format, except it's slightly longer than your usual midterm. It is still open book, open notes. I will bring my calculators. You can bring in anything that is either handwritten or printed prior to the class. All the sample programs that we do in class, you can bring those with you if you want to. I mean, if you think it's going to be helpful, which is probably going to be helpful to some people, just a reminder of, oh, I forgot about how to trace this kind of thing. You can just kind of look it up and go like, oh, okay, so that's how it's done. So you can bring anything that is handwritten or printed prior to the class. It can be printed out of spreadsheets. It can be screenshots, of the video stuff. Can be just something that you write down. It's all okay. You guys can share prior to the test as well. So you can have a study group where each person is responsible for one aspect of the class, and then at the end of the studying, you can copy and paste all the documents, and then during the exam, you cannot talk to each other, but you can bring in like copies of the same material to help you out in the final exam. Are there any questions about the format of the final exam?
I just have a question. What is the URL for the YouTube?
It's youtube.com
Okay. What do I
/someprofs.
Okay. And do I search like Dr. Tag?
No.
Some profs.
That's the name of the YouTube channel.
All right. Thank you.
All right.
I have a
Yep.
question. Is there going to be a practice exam, or is there?
Yep, there will be a practice exam next Tuesday. So you guys are actually better off compared to the other class. The other class has their exam on the 20th. So after the practice exam, they have to wait like almost more than a week for the actual exam, whereas you guys only have to wait 2 days after the practice exam for the actual exams, which I think is actually better, because neither class is going to get another class meeting after the practice exam, except you guys can use that information almost right away, whereas the other class has to wait a little bit of time before they can use it. The exam 2 is all graded, so when you look at X2 Q1 to X2 Q4, you will see the individual score. When you go to your grade book, you can actually see the cumulative score of exam 2. I think a lot of people did really, really well in that exam. I mean, I have a few people who got 100% out of the entire exam, so I thought that was pretty good. There's a new homework assignment on return values. It is sub 3. I will change the due date to next Tuesday because there's no there's no point in making the due date on the same day as the final exam. So I'm going to change the due date not on the 15th, but back onto the 13th. So this way I can talk about the solution to this homework assignment, which is going to be helpful for preparing for the final exam. So that's one thing that I'm doing right now. Yep.
And for the material that's on the exam, will it be up to this assignment here?
It is comprehensive. It will be up to and including the material that we will talk about today. Okay, so this is your new homework assignment. It is sub 3. It is also based on subroutine, and it looks like this. So you have to trace this particular program. And I don't want to name the subroutine in a way that you guys would know what it is, but I think someone in this class can probably recognize what it is, and know what the program is supposed to do. But for the most part, what you really need to do is to follow the mechanism and just trace it and tell me what the program is going to do. It's not going to be a really, really long trace. It is a little bit more tedious than some of the other traces, but it's not really too bad. Okay.
Is the microphone on and the video recording?
The microphone is on, the recorder is on, and the recorder is coming from the right channel. Let me see. Yep, that is. So when you listen to the audio, it's kind of pop. It's like, what? Okay. So are there any questions at this point before I give you one last sample program that is kind of long and a little bit complicated? I just went through this with my earlier class, with the 9 o'clock class, but I think this one is going to be useful. I also noticed half the class is not here because technically speaking on roster when I'm grading, I still have about 35 students, and I think I'm counting maybe 15, 16 right now. Yeah, go ahead.
On the other homework assignment?
Yeah. Oh yeah. I'm gonna go over the sub 2 homework assignment.
Well, it's kind of like a sub thing of it, but
Okay.
I was talking to my friend at UC Davis. He's taking MATLAB or C+.
Mm-hmm.
And I kept talking about 5-out, 5-ref, and he kept calling it a pointer. And I was just like, what's that?
Okay, in C++, there is pass by reference, okay? So pointer is a last resort in C++. So, you have to remind your friend that there is passing by reference in C++. Not in regular C, but in C++, there is pass by reference, which is the explanation that I used in this class does explain, the mechanism of passing by reference in the context of C++.
You've heard of it?
Yeah, I don't talk about pointers in this class because it's a concept that we will go over in cisp300, but pointers is a feature that is somewhat unique to C only, C and C++. There are no pointers in Java. There are no pointers in Perl, PHP, Python, Visual Basic. Even C# does not have pointers. So pointers is a slightly more difficult concept to understand, and it can lead to lots and lots of problems. Yeah, you can wait until the 360. It's actually almost toward the end of 360 that we'll actually start to incorporate pointers in the discussions. Yeah. But for the time being, references, passing by reference is what we need to do, for this class. All right, so this is your homework assignment, for sub 2. What I'll do is I'm going to go through this trace just so that we know what is the correct answer for this particular homework assignment. Alrighty. Okay, so to trace this one, we don't need comments because there are no conditions to evaluate. So we can start with just line number. Are there any global variables in this program? In other words, when you look at each subroutine, all the names referred to accounted for by either by ref, by val, or local.
Yes.
They are all accounted for, okay? Because x, y, z in sub 1 are all parameters. X and y, in sub 2 are also parameters. So that's why we don't have any global variables in this case. That makes the precondition pretty easy to specify because there is nothing to specify. And then we start with the first line that is outside of the subroutine definitions, which is line 13. Line 13 is invoking sub2. We pass 40 to x, and then we pass 30 to y. So the first thing we do is we have to do a return line number to remind us, when we come back from the invocation of sub2, where am I going to continue execution? In this case, it's post because line 13 is the last line of the entire program. And then we have to set up additional columns for the parameters and also local variables, if any, inside the subroutine. In this case, we only have two pass by value parameters, x and y. We do not have any local variables in this case. As by value parameters, we specify the value of those columns when we are invoking the subroutine, not when we are inside the subroutine. So in this case, we know that x starts with a value of 40, y starts with a value of 30, and that's how we set up the three columns that we need in order to execute subroutine sub2. Then we start on the first line inside sub2, which is line 11 in this case. It is the invocation of another subroutine. So we allocate another return line number here for the invocation of sub1. When line 11 is done, we have to continue execution on line 12, so the return line number is set up to be line 12. And then this time we do have three things to set up. We have parameter x, we have parameter y, and also parameter z. Parameter z is the only one that is passed by value. You can see it on line 4. It is passed by value. And we are using a value of 10 to specify parameter z. So we just put the 10 here. X and y are slightly more confusing because in this case I'm using the x of sub2 to pass as a to parameter x of sub1. So this x is passed by value to sub2, but in return sub2 is passing it by reference to sub1. So what we need to do is to find out from sub2's perspective what column is x. Well, column C here. So that means we have to pass that along as a reference, as an alias to sub1. So as far as sub1 is concerned, parameter x, which is passed by reference to it, is an alias of column C. Are there any questions about how we set up column F? Yep.
Say there was a comments section, and that happened to be AKA column D. Is that an issue?
That's fine. If you offset everything by one column, that's okay, not a problem. Because the key issue is how are you going to make use of the parameter on line 5 and line 6. That really is the key. Okay, so likewise, y is an alias of column D because I'm using the y, which is passed by value to sub2, and I pass it along by reference to y of sub1. The y, which is passed by value to sub2, is using column D, so that's why I'm passing column D along by reference to parameter y of sub1. So now I have set up all the columns necessary for the other subroutine, and now we can move on and continue execution in the other subroutine. So let me just zoom it out just enough so that we can see both the algorithm and also the columns. So now we are ready to go into sub1 and start execution inside sub1. So in sub1 we start execution on line 5. On line 5 we have to first compute the sum on the right hand side. The sum on the right hand side is adding x and y, x and z. Z is the easy one, it has a value of 10 already. X is an alias of column C, and column C right now has a value of 40. So we are evaluating 40 plus 10, which is 50. The question is, where am I storing that 50? We are storing the 50 back into x. But which x are we talking about? When we want to find out which x we are talking about, we have to search for that name from right to left. So the first one that we encounter that has a name of x is column F. Column F is also known as column C. It's an alias of column C. So we have to go to column C and update that to 50. And then we move on to line 6. Line 6 needs to compute y minus z first. Y is also known as column D. Column D has a value of 30. 30 minus 10 is 20, and we want to store 20 back into y. But y again is an alias of column D, so it is column D that needs to be updated to a value of 20. Then we are all done with the two statements, the two assignment statements. We move on to line 7, which is the end of sub 1. The end of sub 1 has two things to do. One is to look up the rightmost active return line number, which is this one, to remind us where we have to go to continue execution. And then the second thing it has to do is to deallocate everything that was allocated earlier for this invocation. So all of these are now deallocated. And now we continue execution on line 12. Line 12 is also the end of a subroutine, so we do exactly the same thing. Look up the rightmost active return line number. It is column B. It tells us to continue at post. Make a note of that. And then we have no use of the columns allocated for this invocation of sub2. So we deallocate all of those columns. And then we now continue execution at post, which means we are all done. Yep.
Just a quick question. The values of x and y are also deleted, right, too? Because we deallocated that one too.
Right.
Yeah.
Yep. So by the time we get to row 11 of the entire trace, we would have erased everything already, and there's nothing. There are no variables left for us to observe at that point. All right.
So if you wanted to, you could put in another step to make it so where the values still stay, or have a they're not deallocated.
They have to be deallocated because they are deallocated when we get to line 12. So by the time we get to the main subroutine or outside of the subroutine, they're all gone already. All right. So are there any questions about this trace? Okay. If there are no questions about this trace, I'm just trying to think about what to do next. Let us do the BS subroutine. Because it's going to be, it will be the basis of at least one of the questions in the final exam. So I kind of feel that we should go over that one first. So let's go ahead. I'm going to use the same document. I can post it online. Okay, so here's the subroutine called BS. Okay, there's a reason why it's called BS. It's not what most people think what it stands for. Okay. And this is going to be a quite involved, algorithm. I will upload this file at the end of the class, so don't worry about copying, all the details, because there is a lot of stuff that you have to copy. So instead of spending your effort, copying, spend more attention, just focusing on what I'm doing and what are the mechanisms involved when we execute this algorithm. Okay, so BS goes like this. It has a lot of parameters. The first one is passed by reference. It is called A. The second one is passed by value. It is called B. And it has another one called passed by value called E. Another one passed by value called K. And has a local variable called M. Okay. And some of you, who study, for the previous exam, probably already recognize, well, I have some idea of what this is about, okay? But if you don't, that's okay. We'll definitely talk about it, when we get to this part. The first thing we do is we check whether B is greater than E, okay? That's a pretty good clue of, what we are dealing with here. If B is greater than E, we return false right away. I'll fix the indentation later. Otherwise, we'll go ahead and do something that seems kind of familiar to us, or should look familiar to us at this point. We basically make M the same thing as the floor of B plus E divided by 2. Okay, that's a little bit distracting, all that tearing. Can you do that after class?
Yeah.
Thank you. Okay, so we compute M first, and then we use that as an index and say if A bracket M is less than K, then we do one thing. Else, if A bracket M is greater than K, then we do something else. Else, which means it is not greater than and is not less than, let's go ahead and just return true. Okay, so we have end if here, and then we end the other if, and then we end the subroutine. And define sub. Let me just make the screen larger so we can see the entire thing, hopefully. There we go. All right. So what I'll do is I'm going to fix some indentations first, just so that the algorithm is easier to read. There we go. All right. So the big question is, where's the recursion? I don't see the invocation of BS anywhere from inside BS. Well, those will go into line, they will go to line 12 and also line 14 of this algorithm. So on line 12, I'm going to say, let's go ahead and return something. But what I'm returning is the result of invoking BS again. When I invoke BS again, I'm going to pass parameter A as parameter A without any change. In this case, let's see, since K is greater than A bracket M, so B has to be changed. So M plus 1 is used to specify B. E is still going to use to specify E itself, and K is used to specify K. So those are not changed. And then in the other case, I'm going to do it about the same way, except for B and E are slightly changed. In this case, B is still used to specify B, because A bracket M is greater than K. Okay, so that's right. I use M minus 1 to specify E, and then I use K to specify K again. Okay, that's basically the subroutine that we're dealing with here. Does anyone have any, like, just random guesses of what this is about? Where have we seen these particular names, like B, E, K, and M, and floor?
On a test?
Searching,
Searching.
okay. But it's not linear search, okay? Linear search does not need, M, okay? The use of the variable name M, should kind of immediately, retrieve your recollection of binary search, okay? That's why it's called BS, it's binary search, okay? Okay. But this is binary search in a recursive way. So let's take a look and see, how this is done, and it is a little bit tedious, but it will get the job done the same way as the non-recursive version. Okay, so outside of the subroutine, I'm gonna do something like this. I will just say that the result, or I'll just do a print, okay? I'm gonna print the result of invoking BS. So I'm gonna print the result of invoke BS, and I need to give it an actual array. So I'll just say that I have a global variable array X. I use it to specify parameter A. I use 0 to specify B because that's the index of the first element of the entire array. I use bar X bar minus 1, which is the index of the last element of array X, to specify E. And then I just have to give a particular value to K, which is the value that I'm searching for. So in this case, let's say that's 3. Okay, and that's the entire algorithm. All right, so this one is going to take a little bit of time to explain. So the focus is the mechanism that we use to trace this one. Because there's a lot of copying if you're doing this by by hand. Okay.
I have a quick question.
Yep. Go ahead.
So the print statement, all that does is just allows it to be displayed on the computer screen?
Yeah.
Okay.
Yeah, and I'll show you exactly how to trace that line. Okay, so what I'll do is I'm going to change the way I trace this just a little bit because I need more space horizontally in order to keep track of everything. Okay, we need one column for comments because we do have conditional statements to evaluate, and then we have the print statement, which will also make use of the comment column. We have line number, and then we have one global variable in this case. The one single global variable that we have is the array X. So the array X, I can just make it a 3-element thing, so I don't have to spend too much time to trace this, but it will still be long enough that we can use recursion and illustrate the concepts involved. So in this case, let's say that 3 is not a part. Okay, I forgot about to specify 3 goes to K here. Okay, just a notation thing, but I do want to make it consistent. So we'll make this array having values of 2, 4, and 10. Okay, so those are the values in the array, and I'm looking for 3, which is absent from the array. That's my only global variable. It is an array, and this is my precondition. Excuse me. All right. So now I'm ready to start execution, the execution of this entire algorithm, which starts with line 20. So here's line 20. And we look at line 20 and go like, wow, that's a long kind of statement. But I don't even know what I'm supposed to do with print, but I know that I cannot do the print until the invocation of BS is done, right? Because what I'm doing is I'm printing the result of invoking but the binary search subroutine. So the first thing I have to do is to call the binary search. When it comes back with a value, I'm going to print that value out. But I cannot really do any printing until I'm back from binary search. So the first thing we have to do is to invoke BS. And since BS, when you look at the algorithm, it has return statements. There's 1, 2, 3, and 4 returns from binary search. So because it is going to return stuff, I need to use a return info column and not a return line number column in this case. So return info is going to tell me when I come back to line 20, what else am I supposed to do on line 20? That's the purpose of the return info cell. So we have to say we do have to come back to line 20. When it comes back, I still have the print operation to perform. But what I'm going to print is going to be resolved by that time. So the invocation of binary search is replaced by a single question mark as a placeholder of the return value of the subroutine. So that's one column. The other columns that I have to set up are for the parameters and the local variables. I have parameter A, parameter B, parameter E, parameter K, and local variable M that I have to deal with. Local variable M is easy because all local variables start with unknown values. So column K is just unknown to begin with. Parameter K is also easy because it is passed by value, and I'm just specifying 3 here. So it has a value of 3. Parameter E is x bar minus 1. X is an array. It has 3 elements. So x bar is 3. 3 minus 1 is 2. So E is just 2. It is passed by value, and that's why the value is in the column itself. B is also easy because I just use 0 to specify B. So it is a 0 here. The only one that is difficult is A, because I am using my array X to specify parameter A. Well, I'm combining the two concepts, passing by reference and also the concept of an array. So in this case, A is an alias of not 1 column, but 3. So it is an alias of column C to column E. So in this class, this is how I represent passing by reference using an array. In the other classes, it depends on the programming language. So the mechanism actually involved to pass an array by reference is a lot more complicated when it gets to Visual Basic, PHP, and Perl. C has its own way to do it. We'll get to that part in cisp300, but I'm not going to talk about the mechanism of passing array by reference in C and C++. Java has its own way too. So so this part is really just kind of specific to this class. Okay. Yep.
How's it C and E?
C dash E. So basically, A is not just an alias; it is an alias of multiple columns. It's kind of like
It's an array.
It's a range.
Okay.
It's a range. So it's kind of like when I want you to give me a pile of books from the library. So instead of giving you multiple slips of paper, each one giving you a particular call number, I'm just giving you one range of call numbers. It's like QA 78.5, something dash something. So you have to retrieve all the books that fits into that range. Okay, so it's the same thing here. It is just specifying multiple columns, using one single
everything in that
alias.
array.
Right. So it's an alias of multiple columns. It's like, okay, every time I refer to A, it's referring to this bunch of columns. Is that concept doing okay so far? Okay. All right. So now that I have set up all the columns, I can continue execution in the subroutine. And the subroutine starts with line 7. So now we can move on to line 7. Line 7 has a fairly simple condition to evaluate. It is just is B greater than E? What do you think?
False.
It is false. Okay. So when that is false, where do we go?
Line 10.
Line 10. Okay, line 10. Because when the condition of a conditional statement is false, we move on to the else branch of the conditional statement. So in this case, the else part of the condition on line 7 is line 10. So on line 10, we are going to change m based on b plus e divided by 2. So let me see if how I'm going to do this. Yeah, I have to keep moving things around because the lines are getting too long, and also the trace itself is wide as well. So in this case, I am adding b and e. b has a value of 0, e has a value of 2. 0 plus 2 is 2, 2 divided by 2 is 1. The floor of 1 is also 1, so m ends up with a value of 1. Are we okay with line 10? Okay. After line 10, we have line 11. Line 11 is comparing a bracket m to k. So here's the question, how do we compare something like that? So we first have to refer to A, and what is A? A is column G is an alias of column C to column E. But what are column C to column E? Column C to column E specifies an array. So with an array, I can certainly do indexing using the square bracket. So in this case, I'm using square bracket, and inside I specify m. M has a value of 1 at this point. So that's why I'm using that mechanism to zero in into column D, because column D is the element inside that particular array that has an index of 1. So are we doing okay so far with the execution of line 11, how to get to the value of A bracket M? Even though A is passed by reference and the array is somewhere else, it is the same thing. You look up what we are referring to and say, okay, within this range of columns that we are referring to, which one is my element with an index of 1? Oh, it's column D. Okay. So column D has a value of 4. We're comparing 4 to K. K has a value of 3. 4 is less than 3 is false. Okay, so we'll go ahead and make a note of that. So A bracket M is less than K is false. Where do we go next?
14.
13.
We go to line 13 because this is a multi-branch conditional statement. So we go to line 13, and the result of line 13 is true. Well, we know that part already because we just visited what is A bracket M and what is K. So we know this one is true. Then we move on to line 14, which is the branch corresponding to the condition on line 13. All right, so line 14 has quite a few things to do, and I'm just trying to figure out how to position. I'm going to turn off all the toolbars.
You can just
so
scroll
that-
up because I don't think we need the first 7 lines maybe.
Well,
I would just scroll up.
I can make this one a little bit narrower for the time being. And yep, there we go. Okay, I'll do this. So this way we can scroll this part, individually like that. Okay. So we are now executing line 14. Line 14 has got 2 things to do. One thing is to invoke BS again. The second thing is when BS comes back with a value, I'm going to return that value. But I cannot do the return part until the subroutine is all done. So the first thing I have to do is to invoke the subroutine, to invoke BS again. This will be the second invocation of BS. All right. So when we invoke BS, we have to set up a few columns. The first one is return info. Second one is A, B, E, and K, and it has a local variable M. So every time we invoke BS, we have to set up these columns. Let's deal with the easy one first. Okay, M is a local variable, or is always unknown. I use K to specify K, and the K that is specified that was passed to me is 3, so I'm just passing that 3 along. In other words, the value that I'm searching for is still the same, so I'm just passing that along, each time. On line 14, I'm using M minus 1 to specify E. The M that I have is column K, which is 1. 1 minus 1 is 0. So this E turns out to be 0 as a result. I use whatever B is passed to me to pass it along to the next one, and B was 0. B is 0 being passed to me as a 0, so that's just 0. A is passed by reference to me already. And anything that is passed by reference to me, I'm just going to pass it along using the same reference. In other words, in this case, it is still the same reference, aka column C to column E. Because if someone is passing something by reference to me, I'm going to pass that reference along if I'm required to pass that thing along by reference. Are we still doing okay so far with the parameters? Okay, the only thing left is the return info. Now the return info is not going to be too bad, even though the line itself is really long, because the return info only has to tell us what else do we have to do when we are done with invoking BS. Well, there's really not much left to do on line 14, because when the subroutine is all done, I just have to return that value. So I don't really have to specify a whole lot. I used the wrong cell, by the way. It should be here. But there's really not much to specify. So that's why column L is relatively short, even though the line 14 is really long, but by the time I come back, what I need to do is fairly simple. Okay. So you can see that it's a little bit cumbersome at this point. So what I'll do is I'm going to split the screen also this way. So this way we can kind of keep track of the variables, parameters that we have to deal with at this point. Yep.
Were B and E just up a little bit?
B and
zeros.
E.
And you got zeros. Was that just
B was a zero to begin with. I'm just passing that zero along. E is the one that got changed because when E was passed to me, it was 2. But on line 14, I'm not supposed to pass E along by itself. I'm supposed to pass M minus 1 as the new E, and M was updated to 1. So 1 minus 1
That
is
was
0.
from that furthest column.
Right.
At that
Yep. I'm going to upload this file. So by the time I upload it, if you open it with your monitor, you'll be able to look at all the things, all the items, with one single screen, and that will look a lot more clear. Yes. Years ago, I used to have these questions as final exam questions. And students were able to use the lab at the time, so we were taking final exams in the lab, and they actually have to do this in the lab using, LibreOffice and whatnot.
So this isn't on the final exam?
Something like this will be the final exam. So bringing graph paper will be helpful because graph paper have lines already, so it's easier to align things. It's like, okay, this will be this column here. So I would definitely bring graph paper along.
Yeah, I could use some of that last time.
A lot of printers can print graph paper now. My Epson printer that I bought for like dirt cheap. There's a function that you can just select. I want to print graph paper, and it would just print graph paper. Yep.
This is what I did. Like, I took this spreadsheet from just an example, and I just erased everything and then printed out just the lines.
Yeah, you can print out the grids.
Yeah, the grids. Yeah.
Yep, you can do that too. But I would use a graph paper because some columns
Yeah,
have
but
to
you
be
can
wider.
you can resize and stuff like that.
Yeah, you can resize. Yep. But if you do it, during the test, you don't know ahead of time,
Yeah.
how wide of a column you.
I was
use.
gonna print out a lot for this one, cause like different sizes.
Okay.
Print us some out too. Everybody.
All right. So now that we have set up all the columns for the next invocation of BS, we can now start with line 7 again, because line 7 is the first line inside the subroutine to do something. So we are comparing B and E again, and B is greater than E is still false because they're both zeros. 0 is greater than 0 is false. So now we move on from line 7 to line 10, just like last time. Line 10 wants to compute M based on B plus E divided by 2 and then the floor of that. This is going to get very boring because 0 plus 0 is 0. 0 divided by 2 is 0. And the floor of 0 is also 0. So M just ends up with a value of 0. And we move on to line 11. Line 11 is comparing A bracket M and see whether it is less than K. A is referring to column C to column E. Within those 3 columns, the one that has an index of 0 is column C. Column C has a value of 2. We are comparing that to K, which has a value of 3. 2 is less than 3 is true. Okay, we'll say this is true. And because the condition of line 11 is true, we move on to line 12, which is the branch corresponding to that condition. So now we have to do another recursive call to BS, or binary search. So this time I'm going to be a little bit lazy. I'm just going to copy and paste a few columns and the values, and then we'll just do adjustments accordingly in this case. So we look at these columns and we just adjust. I think I did it.
I have no idea what the columns are anymore.
Yeah. I scrolled, accidentally. Nope, I guess not.
I don't know what's happening.
That's why it's being recorded.
Yeah.
Okay, so we are now setting up these columns R, S, T, U, V, and W. Almost done. They're not exactly correct because I did a copy and paste. Now, where every time you do a copy and paste, you kind of have to make some minor adjustments. So the return info has to be adjusted because we were doing the invocation on line 12. When we come back, we have to finish up whatever is left on line 12 to do, which is still just a return operation. A is passed to A, so that part is not changed. I'm still passing the same reference to column C to E along. B is the one that I need to change here because according to line 12, I'm using M plus 1 to specify B. M is 0 in this case. 0 plus 1 is 1. So B this time should have a value of 1 as a parameter. I just passed E along, so E can still have the same old value of 0. K is just being passed along just to, as itself, so it still has a value of 3. And M is a local variable, so it always starts with an unknown value. Yep.
So this invocation gets all its values from the very last.
From the previous one, except for E. E is the only one that got changed because, except for B, because B is getting M plus 1, so I'm not passing B to itself.
So does it get its values from the last invocation or the very first?
From the previous one.
Okay.
Well, at this point it's the current one because I'm still on line 12, so I'm still using the frame, or I'm still using the columns, to the left-hand side of column R. But these are the columns that we're setting up for the next invocation. So, but I'm not in that new invocation just yet because I'm still on line 12. Now that the columns are all set up, I can now get into the actual new invocation starting on line 7. So now I'm in the new invocation because when you're invoking a subroutine, you always start from the very beginning. So this is basically starting with at the beginning of the new invocation, the last invocation of BS. So on this line 7, we do the same comparison. B is greater than E, except this time the answer is true because B has a value of 1 and E has a value of 0. So after this, we can go to line 8 right away because the condition of line 7 is true. So line 8 is just return true. When you execute a return statement, regardless of what kind of value you're returning, it is the same mechanism, which means we are looking for the rightmost active return info cell. In this case, it's column R. We copy and paste it, and then we just say, oops, to the wrong place. And then we change the question mark to the value that we are returning. What are we returning this time on line 7, line 8? Oops. Excuse me, I forgot to update the line numbers. There we go. On line 8, what am I returning?
False.
I'm returning false, so that means the question mark is just false. Okay, so at this point, did I change anything about the mechanism of executing a return statement? It's doing the same thing, right? It's doing the same thing as in all the previous classes. It is still just looking up the rightmost active return info cell, copy and paste that cell, change the question mark to whatever we are returning. In this case, I'm not returning an integer, I'm returning a Boolean value, but it's the same mechanism. Okay, all I'm doing is changing the question mark to the value that I'm returning. All right, so now that I'm done with that step, I can move on. From line 8, I can go all the way to line 19. The reason why I can go from line 8 to line 19 all the way is because line 8 is the only statement of the then branch of the outer conditional statement. So when this is all done, you have to look for the end if that is matching this if here. That is line 18. But we don't trace line 18 because it is an end if. So that's why we just go all the way to line 19. On line 19, it is the end of a subroutine, so we got two things to do. One thing to do is to look up the rightmost active return info cell, and that is column R. So we just copy and paste it here to make a note of where we're supposed to go and what we're supposed to do at that point. And then after that, we have no use of column R to column W anymore because we are ending that particular invocation. So everything that we allocated earlier for this invocation, we have to get rid of all of that now. So I used the strike through for all of these columns at the same time to basically mark that these columns are now deallocated. And then execution continues on line 12. But on line 12, it is now just return F. So I'm executing return F or return false. And to do that, I have to look up the rightmost active return info cell. It's not going to be column R anymore because that one is now deallocated. So I have to kind of look my way back and find out too much. This would be right. So I have to kind of look back and say, oh, okay, I can see the column L is my rightmost active return info cell. So I'm going to copy and paste that cell over here. And since I'm executing return false, that means I'm going to change the question mark to false here. It just turns out that they're both return statements. Okay, the statement that I'm executing and also the statement noted by the return info cell, they just so happens to be both return statements. But the action of executing line 12 is really just copying and pasting the return info cell and change that question mark to a false because I'm returning false here. After line 12, where do we go?
End up.
Yep, end define sub. Because line 12 is the only thing I have to do for this particular branch. So that means after line 12, I will get to the end of the inner conditional statement. But the inner conditional statement is the last thing that I have to do in the else branch of the outer conditional statement, which means I can exit the outer conditional statement as well after line 12. So that's why after line 12, I can skip all the way to line 19. So now we get to line 19. Line 19 has got two things to do. The first one is to look up the rightmost active return info cell. Just copy and paste it because this will remind me what I need to do after I get back from this invocation. And then the second thing it has to do is to deallocate the columns corresponding to the invocation that is ending. So I copy and paste all those columns, headers, and then just do a strike through. And now I'm ready to continue execution on line 14. Line 14 is right here. Okay, well, actually, I don't even need to show that here because line 14 is no longer like this. Line 14 is really just return false. So now I can execute return false, which means I need to look up the rightmost active return info cell. The leftmost active return info cell is column F in this case. So if I look up column F, it has this content here. So all I need to do is to copy and paste this over here, change the question mark to the value that I'm actually returning. What value am I returning? So false. Okay, so I'm going to put the false here. And I'm done with line 14 at this point. After line 14, I get out of the inner conditional statement. But since the inner conditional statement is the last statement of the else branch of the outer conditional statement, I'll also be exiting the outer conditional statement. So I'll be continuing execution on line 19 at this point. So we just say, okay, we are now on line 19. Line 19 once again has got two things to do. We have to look up the rightmost active return info cell, do a copy and paste, and then we have no use of those columns anymore. And this time I'm just going to copy and paste from here. Easier, right? Well, missing M. Okay, so now that I have all the columns deallocated on line 19, I can now continue execution on line 20. Line 20 is now just printing a value of false, So I'll just use the comments column and say I'm printing a value of false over there, because there's really no other way to indicate what you're printing other than in the comments. After line 20 executes, I'm done. Get to post.
Also, there's no real returning anything, just.
Yep, I'm just printing the result of what I'm looking for is not in the array. The value of 3 is not in the array. That's what it means. Okay, so as an exercise, don't turn this in because I'm not going to grade it. It's not a homework assignment. So what you can do, or what you want to do to study for the exam, one thing you can do is change that 3 to a 1, to something that is actually in the array, and see what happens with this algorithm. The trace will be slightly shorter because you won't have to go all the way to the case where B is greater than E. So it will be one invocation less than what we are dealing with here. And it will also return a different value as a result. But you want to at least give it a try and see what it does. Okay? It's a good exercise because we already know for the most part what it does, but this time you'll be exercising a slightly different branch. Yep.
You should zoom it out, see how.
Sure. Okay, let's zoom out, maximize the application, get rid of all the splits, and just zoom out until it fits onto the entire screen. It's not too bad. We just use all the way up to column W, and only 25 rows. 25 rows and up to column W. That's not too bad. Yep.
I was curious about line 14 on the algorithm.
Line 14, okay. So let's take a look at line 14 of the algorithm, which is this one here. Say again?
Why is B referring to B?
Why am I passing B to B?
Yeah, because like on line 12, it's just a single arrow.
Oh, you're right. Okay, it's not supposed to be double-sided. Thank you.
Oh.
Okay, good catch. Because it's not passed by reference. We only use a double-sided arrow when we pass something by reference. In this case, because it is passed by value, we only should use a single-sided arrow. Thank you. Good catch. All right, any other questions? No other questions? All right.
I think
So
we're absorbing still.
still soaking, right? But the point is, there's only one additional thing in this trace. It is passing an array by reference. That is the only new concept involved in this particular trace. Everything else is stuff that we already know. Are there any particular question about this one? No? Okay, let me save it first and upload it before I forget. I have a tendency to forget stuff like that. So I'm gonna save it first.
I wonder what people would think who aren't here and just look at it.
Say again?
People who aren't here today and they look at it.
Well, since I didn't put anything on the whiteboard, technically speaking, for people who are missing, not here live, if they watch the recording, they should still be getting as much as you guys are getting.
So let's put some stuff on the whiteboard.
Put something on the whiteboard, like actual questions in the final exam, right?
Yeah.
And they can only hear audio.
Well, not to do anything, but actually say that in the video, so that people who are missing the class think that I'm putting something on the whiteboard that you guys are getting, but they're not getting.
They come in and it's like, what was the thing on the board?
They don't get to ask questions.
Or say that I don't put anything on the whiteboard, but I actually do. Which is worse. Okay, 2014, 05, 08. Well, I'm not going to do anything like that, because some people might have, actual legitimate reason why they cannot be here. Maybe the car breaks down, something like that.
Yeah.
So I don't want to punish people,
As soon as that no drop date comes up, everybody's down.
Well, some people,
It is really, really busy life.
Got other stuff to do.
Well, I'm not here to tell people how they should study or how they should attend classes or how they should view their, the learning process. If they want to get, some people are happy with just a C because that's all they need to move on to the next class or to get transferred. I cannot say that is not. I'm not here to judge.
I am.
It took a while to kind of figure out how to do the homework, but then once you got it, it looked so easy. It was kind of confusing, like, because I got it, but I was staring at it for like an hour. Like, is this right?
The last one, Subroutine 2.
Yeah, yeah.
Man,
I mean, it took a while to figure. Yeah,
it was
I had to
so
watch like
short.
2 or 3 of the YouTube videos and then go over some of the notes on the topic.
I was
The thing that
concerned.
sucks the most is my husband's a computer programmer. He works for the state. And I'm like, hey, help me. He's like, I don't know what you're doing.
Yeah, I've asked people for help too, and they're like, I don't know what this is.
It was like the logic behind.
Well, there are three types of programmers. Okay, three types of people who write programs for a living. The first type are programmers who are self-taught, who have never who have taken very few classes, and for the most part, just learn how to program by reading books and by practicing. The second ones are the ones who go through formal education, to learn how to do programming, but not taught by me. And then the third ones will be the ones that go through my classes.
Yeah, see, and his dad was a computer programmer too, so he kind of just learned growing up.
There is a lot of stuff you can do it just by doing it, just by observing how other people do it and doing it. But there are things where if you understand the theory, you will be better off. It will prepare you. It will better prepare you to learn new things. So I think we all learn with a mixture of those two approaches. Which is sometimes we learn by doing it by hand, and other times we have to kind of sit back and go like, okay, I have done everything that I can possibly do just by observing how somebody else is doing something. Now I have to go back to the theory and understand a little bit more about the theory before I can continue to do additional programming. So there's that.
It's like implementing conditional statements into an actual code. It's
Mhm.
really challenging to get the result that you want. Actually come up with that algorithm yourself.
Well, that's going to be the main challenge of cisp 360, because in cisp 360, I'm not going to give you programs to trace. I will be giving you an objective of a program and say that, okay, write a program to do blah, 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 blah. And then you have to synthesize the program. The challenge is actually two-folded, because the first challenge is the programming language itself. In this class, you have to understand what I'm writing, you have to understand the notation that I use, but for the most part, you're not writing the pseudocode. So you don't have to worry about, oh, what if I miss the then word, okay? Even if you do that, because it's pseudocode, if you miss THEN in a line that starts with if, nothing too bad is going to happen. I'm not going to take points off. It's pseudocode. But in C and C++, if you miss a semicolon at the end of a line, it's not going to compile. If you misplace a closed curly brace, really bad things will happen. Okay. The worst part is if you misplace a closed curly brace, which acts the same as a end if and an end while and end define sub in this class. Because in all of those ends, they use the same symbol, like a closed curly brace. If you misplace a closed curly brace, it is it's just a few lines down from where it's supposed to go. There's no syntax error. Syntactically, it is okay, but the program doesn't mean what you think it should mean anymore.
And then trying to find that is.
And then trying to find that is difficult. So that's why when in cisp 360. Instead of tracing, which is very tedious, time-consuming, and kind of long, instead of doing that, you'll be using a debugger. In other words, you'll be using a tool that allows you to stop the execution of a program and examine the values of variables. So it's not exactly a trace because it doesn't keep a historical record of how something got changed over time. But at least it gives you the ability to say, from here on, I want to know what is happening to my variables. Or what happens to my decision making. Okay, here's a conditional statement. Which way am I going? I think I should be going this way, but you know what? The program is going the other way. Why is it going the other way? Then you can start to debug your program. In fact, since we have a little bit of time left, if there are no questions, I can kind of show you what cisp 360 will look like in terms of what type of program we're dealing with, and also what type of tools we'll be dealing with.
I have a question about Day 60. Is it a two-part class? Like you go 1 hour lecture and then 1 hour
Okay,
lab?
that's a good question. So we'll answer that question first. What is your question? Let me see if I can.
forgot.
Oh, I'm sorry. You don't have a screen recorder in your mind, do you? That would be helpful, right? I mean, a mind recorder,
Oh my gosh.
yeah, so you can just kind of roll back and say, oh, okay.
And people's minds work like that.
Well, some people have exceptionally good memory. Yeah, I don't.
I hate that. I
You
want
hate that. It depends on what type of classes you're taking. With a class like this, rote learning is not going to be helpful with this class.
What is it?
Rote learning, you're basically just memorizing steps, and you can reproduce something that you have seen before, but only in a literal way. Like if I see step 1, 5, 6, 7, then I can repeat 1, 5, 6, 7. But you cannot. Those people usually cannot alter the sequence to make it adapt to a new situation. Some people can have super memory, like photographic memory, and the intellect to deal with abstract thinking. People with a combination of those two tend to be extremely successful. Doesn't matter what they do. One person like that is called, I'm pretty sure I brought it up in this class already. That person is John von Neumann. The guy who came up with the architecture that we still use these days, with all of our modern computers. The same guy who participated in the making of the first hydrogen bomb, and many, many other things. He was basically the genius of geniuses. Other geniuses at Princeton University look at this guy and go like, wow, that is a genius. And he would play loud music when he's working. And guess who's next to his office?
Einstein?
Yep, Albert Einstein. Who probably did not appreciate all the noisy music that he was playing. Yeah, so there are people like that. Okay, so let's go to the fall schedule and look at the classes here. Okay, so we have technically we have 3 sections, because Antos actually has 2. He has 2 sections, and I have 1. The way you read this is the actual meeting time. Let me zoom in first. Okay, so the only time that we meet for this class is quote unquote for the lab. Okay, but I don't like to do lab interactively, like face to face, and then put the lecture online. So I'm gonna do the reverse. I can pretty much change the way I use the time, but the time that the class actually meets is from 10:30 to about 11:50. So it's about the time frame as this class, except it's on Mondays and Wednesdays. It's in a room where you have computers in front of you. So if you like to take notes using a computer, it's great. If you want to repeat experiments that I'm doing in class, great for that purpose as well. So I'll be doing lecture during that time, and then when the homework assignments you have to basically do on your time, which is basically quote unquote online. The TPA is basically just online and not scheduled.
Okay.
Okay, so it's this class, CISP 360 is 4 units. 3 units are for the lecture, so it has the same amount of lecture time as this class. The 1 remaining unit is called the lab time, so you will basically be spending time to actually work on getting the programs to work. So you'll be constructing and writing programs and get those to work. It will be helpful in this class, since the programming part is online, to have your own recorder set up, screen recorder. So this way, when you guys have questions, you can basically give me a screen recording that you upload to YouTube and basically say, okay, this is what I did, I wrote a program like this, and this is how I run the program, and up to this point, it is still doing everything correctly, but at this point, it's going to the wrong branch. So when I watch your own screen recording, I can actually see better, what you're doing and what your program is doing. So that's, one thing that we can talk about when we get to that class. But just to give you a preview of what kind of tools that I'll be using, or tools similar to what I'll be using. You'll be writing program using, basically just a plain editor. Mousepad is the one that I use, in this platform. I'm using Linux right here, so that's why it's a slightly different tool. And your C program is going to look kind of more cryptic than the pseudocode that we deal with in this class. So let me just kind of give you one program that computes the sum of two integers and print it out. Okay. So there are things that is kind of cryptic, like, why do we need to do this? I mean, what includes standard I/O? I'll explain those, in the other class, but not right now. Okay. So here's a subroutine called main, and this is how we define the subroutine in C. It doesn't start with define sub, main. It's just int main void, and I'll explain all of these later. But basically, what curly braces are useful for is to begin something and close something, the end of something. But it doesn't. It's the beginning and the close of subroutines, conditional statements, and loops. And it's the same notation. There's no, if and end if. End will if it's followed by open curly brace and close curly brace. So in this case, I'm just gonna print out, the sum of two integers. So I just, this is invoke. Okay, there's no invoke word in C and C++. You just name the subroutine that you're invoking, and that's it. So it's very concise. It's very nice in that way. When you pass parameters, you don't have to name which parameter this value is going to. It is done by positioning. So if I say 23 and 47, that means 23 goes to the first parameter of sum, and 47 goes to the second parameter of sum. And then I can go back and define sum. This int specifies that sum returns an integer, and then we can name the parameters here. So parameter x is the first one, parameter y is the second one. So when you pass the parameters in the invoke statement or the invocation, you don't say that 23 go to x because it is done implicitly by position. So 23 goes to the first parameter and 47 goes to the second parameter. The return statement is pretty much the same way as we do it in this class, except in C, every statement that is not a block or compound statement needs to end with a semicolon. So the semicolon is used as a terminator for a usual assignment statements or subroutine call. So this is a very simple program to print the value of 23 plus 47 using a subroutine sum. So the notation is different from what we use in this class. Okay, so now that the program is done, okay, I'm going to save the file. Save.
This entire semester, I've been wondering how this is gonna help out in the next class, because I'm like, man, this doesn't make any sense. I don't know what I'm doing, but I understand everything that you just did. So
Yeah.
Right, because
Yeah,
even
no,
though the notation is very different from what we do in this class, the meaning of an invocation is the same. The meaning of returning something is the same. The meaning of a conditional statement is the same. A loop, the same. So it's the
Application. Application.
It's the application or the meaning of the constructs that is important. The syntax can change very rapidly. If you compare C, C++ to Python, it's like completely different. But you know what? When you look at Python, it has the same elements as what we talk about in this class. Variables, subroutines, conditional statements, loops, parameters, and so on and so forth. And those things are fairly universal. There are very few programming languages that what we talk about in this class does not cover. Very few, not zero, but few. Okay, so, but in the other class, when you're done writing a program, I just saved it into the temp folder, so I'm going to change the temp folder here. I haven't decided yet, how to get this step done. Get this step done when you take the next class. But at the lowest level, I can use a command line program to do everything. So I can basically just say, compile the program to become an executable, and then I can just run the program, because it prints the value of 70, which is 23 plus 47. Now, when you're debugging the program, if it's not doing what you think it should do, then you can use GDB or debugger to help out in the process. And in this case, you can list the program that you're debugging. Oops. Okay, I forgot to do something when I compiled the program. I'm supposed to do a -G here to specify include debug information. So now I can go into the debugger. It can show me the program, and I can put a breakpoint on a particular line. Let's say line 5 here. I can run the program, then it stops exactly on the line that I asked it to stop on, which is line 5. And then at this point I can examine what is variable x. It has a value of 23. And what is variable y? It has a value of 47. And then I can also single step through the program, which means I'm only performing one line of code at a time. So I can use single step. Now it goes back to the main subroutine, and so on and so forth. Okay. Well, it's actually continuing on to printf, but that's kind of besides the point. Besides what I want to, illustrate here. These are the very basic tools. I'm probably going to use a tool that is slightly more user-friendly. For those of you who want to get a head start, because I think Antos uses the same tool. One is called code blocks. So code : blocks. And the other one is called, I think it's called dev C++ or dev++. I cannot remember. I have to look it up. But code blocks is definitely one of those tools that is more user-friendly compared to what I just did. I'm just going to look up your code blocks here.
Sorry, code blocks for Windows 8.
Yeah, code blocks is nice because you can run it in Windows. You can also run it in Linux. So it's pretty much platform independent. You can get it for Mac OS 10 if you want to.
It didn't work for Windows 8. It just was not working.
Nothing works in Windows 8 except for Microsoft products.
Yeah, pretty much.
Windows 8 is I think the first version of Windows that actually enforces the vendor of software that you install. If you try to install any software that is not in the, I think it's still called the Secure Computing Consortium, then it will give you like lots of trouble. Like, are you sure you want to do this? If you do this, you can end up tainting your operating system and so on and so forth. I have not used Windows 8 for open source programs, so I don't know exactly. It's terrible.
At least now I know what my computer's doing. My computer's popping that stuff up all the time. Are you sure you want to do this? It's like I'm trying to update my Adobe Flash.
Oh.
And it's just, I wouldn't expect that, but it's just, my computer's been
Well,
going
yeah.
everywhere.
Well, at least it will let you do the update. It's just asking whether you want to do it or not. If you try to install any open source software in Windows 8 or 8.1, I think it triggers a lot of stuff that happens and say you cannot do this.
It's not my Windows stuff.
You can do it. You just gotta kind of
Go through a bunch
take, brute force, take your computer to the Windows 8 to the curb, and then
There's always ways, yeah. there's
once you
always
do
ways.
that, once it learns its lesson, then it tends to work nice.
Or you could just use Linux.
Yeah, I'm
Actually
just
works
using
pretty well
Linux
after
here. Yeah, well, I don't have code blocks installed here. Maybe not. Oh, I do. I do have code blocks installed here, and this is what we call an IDE, for integrated development environment. Let me just kind of show you quickly what it looks like, because it's nice because everything is kind of self-contained. So everything is kind of self-contained, and you can go to File, and then you can say New, and then you can start a new project. So instead of going through all those, individual steps, this one is kind of more point and click. But below, down below, code blocks, if you look at, the actual underlying mechanism that is working in the background, it's the same stuff that I did, using the command line, terminal thing. It's really the same thing. So I haven't really quite decided, which way to go, whether to use a full GUI tool or just go, go with the basics. I personally like to go with the basics because once you know the basics, moving from a basic thing to the GUI is easy, but the other way around is not.
Yeah, you should maybe either do a combination of both, or start them off with, because you need to know how to do some command prompt stuff. Some
Yeah.
people just don't know how to do it.
Well, eventually you will have to do that. I mean, it's really something that people have to do as a developer. That's something
Well,
that
some
has to be
servers
done.
don't even have GUIs. You're just doing stuff from command prompt, so
Yep.
you don't know what to get in.
Yep. So how many people here are moving on to cisp 360? Okay, because I know some majors, for instance, Art New Media does not require moving on to C++. But which programming languages are you guys using? Python?
And Mel. But Mel is a
But what does it resemble? Because there are, it looks like C++. It probably doesn't have pointers, so you'll be okay without understanding pointers. Do you see resemblance of the concepts though? I mean, features that you find in the programming languages that you have to deal with, as opposed to the pseudocode that we talk about in this class?
Yeah, I can totally because this is my first semester of scripting in Maya, so coming here and learning stuff, I can totally take it over there and like, oh, that's what we're doing.
Oh, okay, all right. But you can model, if someone gives you a program in Maya, is it Maya, M-Y-A?
M-A-Y-A.
M-A-Y-A, Maya. So if someone gives you a program in Maya, you can kind of mentally track, what that program is supposed to do, right?
Yeah.
Okay, so that's the purpose of this class, is to give you the ability to understand programs.
I'd taken a Linux class several semesters ago, and we were touching on some scripting stuff, and I had I was able to kind of do some of the projects. He didn't, hammer you for not knowing programming, but I wish I kind of would have known a little bit more, because it would have made more sense.
But programming is actually useful in fields other than just writing programs, because it's a tool. It's not really just it's kind of like a knife is a tool, but it's not really just useful to hunters. You use a knife to peel oranges. It's just a tool. You don't have to be a professional to appreciate the skills and techniques of using a tool.
I want as little people to know how to program as possible, so that I have no competition. That's just a joke.
Well, I think there will be a lot of people, with programming ability coming out of, some, other countries. I mean, there are two really populous countries that are pumping out programmers left and right. So what you need to do is to think about, what makes you marketable as a programmer, because, you have to find your job, here in the United States, and a lot of companies, especially larger ones, they want to save money, and they want to offshore, and also, just, contract out the programming work. That can only work up to a certain extent, because depending on the education, of the people involved, and also whether you have a second major, like either a second major or a minor when you go to college, that can be very helpful. There was a student in a previous class, in the 9 o'clock class, and I think she has a bachelor's degree in plant science already, and she's planning to get a master's degree in computer science. So you would think plant science and computer science, I mean, even though both have science at the end of the word, at the phrase, they're not related. But it's a good combination, because having an understanding of plant science gives that person an ability to do modeling. You understand the modeling of, like, how forests, affect, climate and stuff like that. Now you can apply your computer programming skill to finish the modeling. So now you can basically say, if we continue to, get rid of, forests at a certain rate over time, what is going to happen? Or if we, on the other hand, if we, plant additional trees to extend, a forest, what will happen, over time? And that's, really useful skill set, because a programmer doesn't have the understanding of plant science and vice versa. But a person who understands both sides is going to be valuable.
I thought about that with having robots take care of like Disneyland, all their hedges and stuff. If you could have the robots, form all those hedges and stuff, that's so much money, because they pay just crazy amounts of money for
Well, things are changing more rapidly than people think it was possible. Now you can buy a $400 drone, a quad chopper, and use it to film special effects stuff that would previously cost people like at least tens of thousands of dollars just for a 3-minute clip. Now you can just buy your own $400 drone and fly that, and take all this all the footage and be done with it. $400. I know $400 is not chump change, but compared to what people used to have to do to do the same thing, It's insane. I mean, just go to YouTube and look for, drone videos and see what civilians have done already, with all those drones.
I was mowing the lawn and somebody was flying a drone in the neighborhood.
Did you shoot it down?
I was shocked. I was like, whoa.
Well, eventually.